So, we will learn about arithmetic sequence. Today we will learn about arithmetic series. What does it mean? Series is when we add first n numbers of the arithmetic sequence. And let's start from considering the next question. How we will find the sum of first 100 natural numbers? Of course we can do 1 plus 2 plus 3 plus 4 and then log. Not very efficient way. How we can do it more efficiently, quickly and simply? Any ideas? I want to add, yes?
I only know this because I just read the paper, but there's like, you take the part on the first and then the second and then...
If you add one first plus last, 100. 1 plus 100 equals 101. If you take the second plus second last, we will get 101. If you do the third and third last, will be still 101. They always will be adding to the same number. How many such pairs will be in 100? 50. So we just can do 1 plus 100, first plus last, times, we have 100 divided by 2 pairs, 50 pairs. So that will be 101 times 50, so will be equal 5050. So if you add first 100 numbers, first 100 natural numbers will be 5050. Now let's expand it to any arithmetic sequence. And in any arithmetic sequence, we will have, if you will add first and the last, if you have arithmetic sequence, first term and second term will be a plus d, so on. And always will be first plus last, will be exactly the same as second plus second last. Third plus third last will have same number. So sum of n terms of arithmetic sequence, we call it series, Sn, sum of first n numbers. We can do first term plus last term and times by half of the numbers in the sequence. So this is a formula for arithmetic series. But usually we have first number and common difference. How we can incorporate it? What will be the last term if we have n terms? Using the formula for nth term of the arithmetic sequence, that will be a plus what?
n minus 1.
N minus 1 times common difference. Substituting it here in the formula that we derived will give us Sn equal a plus n minus 1 d times n on 2, and simplifying it we get 2a plus n minus 1 d over 2 times n. So there are two ways how we can find sum of the first n terms of arithmetic sequence. Make sense? Let's consider a couple examples from your booklet. So let's, from 3C, let's consider example. Let's say example 4. The sum of the first, example 4 from the booklet from 3C. we have that sum of the first 4 terms, S4, equals 58. Sum of the next 4 terms is twice that number. Next 4 terms will be S8, sum of all first 8 minus sum of first 4. That will give us sum of the 5th, 6th, 7th, and 8th when we sum first 8 and minus sum of first 4. Make sense? And it's equal, it says double this number, so equal 116. Now let's substitute formulas instead of S4 and S8. We can write that it will be S4 will be 2a plus.
Isn't S8 just 116 because it's 2 times?
No, it says sum of next 4. So it's sum of 5th, 6th, 7th, and 8th. Which is, to get it, we need to take away sum of first 4. Make sense? So we have S4, using the formula that we just derived, will be 2a, I write a, looks like d, 2a plus 3d, because n minus 1 is 3d, times 4 on 2, 4 terms, n equals 4 divided by 2. So we will get 2 times 2a plus 3d equal 58. Let's substitute the formula for series, arithmetic series, sum of the terms to this one. So we get that S8, what will be S8? Will be 2a plus how many d?
360.
How many d? How many? In the formula again, 2a plus n minus Sn equal 2a plus n minus 1d divided by 2 times n. So when we S8 will be 2a plus 7d and it will be times 8 by 2 minus S4, which is 100, which is 58, so minus 58 equal 116. Rewriting this equation, I substitute instead of S4, substitute 58. Rewriting this equation, we will get 4 times 2a plus 7d will be equal 116 plus 58 is 174. We've got 2 simultaneous equations for a, which is the first term, and d, which is a common difference. Let's solve those simultaneous equations. Probably let's rewrite it, open the brackets. So we have, we divide by 2. Here we divide by 2, so we have 2a.
Is that a d or an a, Mr. B?
2a plus 3d.
Looks like I was confused. I thought it was a d.
Sorry, this is a. This is a. My pen right. 2a plus 3d equal 58 divided by 2, 29. And second one, divided by 2. So we get 2 times 2a plus 7d equal 174 divided by 2 will be 87. expanded brackets, 4a plus 14d equals 87. So we have two simultaneous equations. Let's multiply this equation by 2 to eliminate a, so we'll have 4a plus 6d equal 58, and then we subtract this equation. From this equation we will get 8d equal, I will make arithmetic mistake there. Not all correct. AD equals 29. So D equals 29 on 8. By the way, common difference does not have to be a whole number, it can be fraction. So that's it. So we found D, then we can substitute this D into any equation. I will suggest the always simplest one. Substituting the simplest one, so we have 2a plus 3 times 29 on 8 equals 29. So we have 2a plus 87 on 8 equals 29. 2a will be equal 29 minus 87 on 8, 29 times 8, 160 and 72, 232 equal 232 minus 87 on 8. So we have 232 minus 87, 13, 45, 145. So we have 16a equal 145, a equal 145 on 16. Double checking that I have not made yes, it's correct. So we found the first term and the common difference. That's how we're dealing with the arithmetic series. Make sense what we did? Okay, like, subscribe and donate to help fight terrorist countries and organizations like Russia, Hamas, Iran, etc. Support Ukraine and Israel.